Lesson 5-1, the coordinate plane. And in this lesson, you learn to graph ordered pairs on a coordinate plane and to solve problems by making a table. Why is it important? Because you can use graphing to solve problems involving geography and cartography. Okay, let's take a look at this real-world application on landmarks. In 1988, as part of Cincinnati's 200th birthday celebration, the city created parks along the Ohio River. They sold over 33,800 personalized bricks that were placed in the pathways in the parks. However, people had difficulty finding their bricks, so in 1989, Frank Albee of Business Information Storage, BIS, developed a master directory in which each patron's name was listed along with the section of the park and the column in which his or her brick was laid. BIS then added locator bricks to identify the columns in each section. Okay, so the system that they used for this, okay, in Cincinnati to help locate the specific site of each brick, okay, in mathematics, points are located in reference to perpendicular lines called axes, okay, and the axes that intersect at their 0 points, a point called the origin, the horizontal line called the x-axis, and the vertical line called the y-axis, divide the plane into 4 quadrants. Okay, quadrants are numbered as shown at the right, this right here. Okay, notice that neither the axes nor the point on the axes are located in any quadrant. The plane containing the x and y axes is called the coordinate plane. So a little bit of a review. This is what we call your coordinate plane. This is your y-axis, which is your vertical axis, and your horizontal axis is your x-axis. Okay, and you in the middle is your origin right here, and this is quadrant 1, quadrant 2, okay, quadrant 3, and quadrant 4. Okay, so with that, we talk about coordinates. The first number, or the x-coordinate, corresponds to the numbers on the x-axis. The second number, or the y-coordinate, corresponds to the numbers on the y-axis. The ordered pair for the origin is 0, 0. So the origin will always be 0, 0. Okay? And we just define the x and the y coordinate. Okay? And they're called ordered pair, if you remember from last year. Why are they called an ordered pair? Because it's always in the order of x and y. Okay? Moving on, to find the ordered pair from point Z, right here, this is point Z, okay? To find the ordered point Z shown, first follow along the vertical line. So you always follow along the vertical line, okay? Or the line going up and down, okay? Through Z to find the x-coordinate on the x-axis. So go through Z, vertical line, until you find the number on the x-axis. Okay, and along the horizontal line of through Z to find the y-coordinate on the y-axis. So first go to x, you'll find your x-coordinate, and then go to y horizontally, you'll find your y-coordinate. The number on the x-axis that corresponds to Z is 4. So this is 4 right here. Okay. The number on the y-axis that corresponds to Z is -6. So this is -6 right here. Okay. So thus, the ordered pair for point Z is 4, -6. This ordered pair can also be written as Z. Okay, 4, -6. The coordinate of the x-coordinate of Z is 4, and the y-coordinate of Z is -6. And this point is also located in quadrant 4. Okay? That's a little bit of a review of what we've been doing since 6th grade. A table is often used when working with ordered pairs. It is helpful. It is a helpful organizational tool in problem solving. So let's look at this one. Write an ordered pair for points E, F, G, and H, shown at the right. Name the quadrant in which each point is located. Use a table to find the coordinate of each point. Okay, So let's look at this one. Point E is this. So that means you read the x-axis first before you read the y-axis. So this is 1, 2, 3, 4. 1, 2, 3. This is 4 and that is 2. So E has an x-coordinate of 4, y-coordinate of -2, not 2, sorry. And your ordered pair should be 4, -2. And it is located in the 1, 2, 3, 4th quadrant. Okay? Point F has an x-coordinate of 0, right there. It has a y-coordinate of -5. The ordered pair is 0, -5, and it does not belong to any quadrant because it lies on the y-axis. Anything that lies on the x or the y-axis does not belong in any quadrant. Point G, okay, is 3.5 as your x-coordinate right there. Okay, and the y-coordinate is 4, so the ordered pair is -3.5 and 4, and it belongs to quadrant 3. Point H, x-coordinate is 6, okay, right there. -6, and the y-coordinate is 3, so your ordered pair is -6, 3, and it belongs to quadrant 2. Okay, pretty simple. Take a look at this one. To graph an ordered pair means to draw a dot at the point on the coordinate plane that corresponds to the ordered pair. This is sometimes called plotting a point. When graphing an ordered pair, start at the origin. The x-coordinate indicates how many units to move right, okay, which is positive. If it's positive, you're moving right. Or left, which is negative. Okay, remember this because as we go through linear equations, you know if it's positive, it goes to the right or going to the up. And if it's a negative, it either goes to the left or going down. So the y-coordinate indicates how many units to move up positive and down negative. Okay, so plot the following points on the coordinate plane, -3, -5. Okay, so -3, -5, we start at the origin and we move, okay, left 3 units since it is -3, so 1, 2, 3 units, -3. Then move down 5 units because it's -5. The y-coordinate is -5, so 1, 2, 3, 4, 5 right here. So this is point N. Okay, and the next one is -4.5 and 8. Okay, that means in this case we start again from the origin, and from the origin, okay, move left 4 units, because this is -4.5, so 1, 2, 3, 4, 4.5 units, I'm sorry, and then go up 8 units, 1, 2, 3, 4, 5, 6, 7, oops, lacking 1 there. So if that is 8 right there, that is your dot. This is point K. Okay, and last one is 6, 0. Okay, 6, 0. When you want to plot 6, 0 again, we start with 6. That means start at the origin, move right 6 units because it's +6. Okay, so 1, 2, 3, 4, 5, 6. And since the y-coordinate is 0, we don't do anything. So this is now your point C. Okay, the point will be located on the x-axis. Draw a dot and label it point L. Oops, sorry, not C, point L. Take that out. There you go. And let's rename it point L. Okay, let's take a look at the next example. Each point in the coordinate plane can be mapped by exactly one ordered pair. Okay, and each ordered pair names exactly one point in the plane. Thus, there is a one-to-one correspondence between points and ordered pairs, which brings us to the property of points in the plane, the completeness property for points in the plane. Number 1, exactly one point in the plane is named by a given ordered pair of numbers. And number 2, exactly one ordered pair of numbers names a given point in the plane. Okay, now how is this applied? Let's take a look at this example. On city and state maps, letters and numbers are usually used to locate landmarks on the map. The number representing the horizontal coordinate is usually listed first, followed by the letter representing the vertical coordinate. However, unlike a coordinate plane where a specific point is denoted by an ordered pair, the coordinates of a map define a region or sector in which a landmark is located. Okay, so let's use this skill. And let's take a look at example 3. Use ordered pairs to name all of the sectors that Interstate Highway 35 passes through in the map of San Antonio, Texas, shown below. So we need to find Interstate Highway 35, which is this one right here. Okay, Interstate Highway 35. Right there. Okay, all the way down there. Now, if you notice, if you follow that particular interstate, which goes all the way back there, right there, okay? So that's Interstate 35. So it's asking, use ordered pairs to name all of the sectors that Interstate Highway 35 begins. So let's analyze this problem. Since we know where Interstate 35 is, I-35 begins in the southwest corner, right here, and extends to San Antonio to the northwest corner. So part of it shares the same path as I-410, okay? So I-35 goes through 1D, right there, okay, right here, and continuing to 2D, right there, and then southeast corner of 2C, so you have 2C, okay, turning upward to 3C, right there, and across southern portion of 3B, all the way up there, okay. Sharing a path with I-410 through 4B and exiting the map at the eastern edge of 4A, okay. So that's where it, that is all the sectors where Interstate 35 passes through. Okay, easy lesson. So this is the end of it. Thank you for watching.